All right, so what are we doing? We're doing some CSCI. This is our seventh day of lecture. I can't even start out spelling CSCI right. We're off to a good start. CSCI 2. We're doing singly linked list today. And we're going to start off with the principle of what's going on. Normally when we have like an array, we'll call the array A, fuck it. We'll call it ARR. We're sending it and we have to preordain the size of it at compile time. Sucks. So we don't want to do that. This is stuck in sequential memory. There was a lot of things we talked about why this sucks. We're going to make our own linked list. Linked lists do some shit like this. We'll have a pointer A. Well, I'll call it LL. Let's call it LL. I'm going to use A in a second. LL, and it points to the first square, and we want it to point somewhere else to another square. And then it could be pointing up here to the third square. And that one's pointing over here to a fourth square. And so it's anywhere in memory. It's fucking awesome. It could just go where it needs to be. Stuff got unruly, didn't it? Got hella loud. So each of these little squares is called like a node. We call them nodes. And right now we're building a singly linked list, which is one way. It's one direction. When we do doubly linked lists, we'll have arrows going the other direction. That adds a little more to it, but we got to start with singly linked lists. And so like that was just a nice picture. To start off, like what we're really going for is we want something that looks like this. It's got to store two things. It's got to store the value that we each have in each of the boxes, value 1, value 2. That wasn't value 2, that was value 2 right there. This was value 3, and that was value 4. And it needs to store information to where the next box is, the next node. So we'll have like a box for values and a box for our pointer. So we got two pieces of information. We're going to need that when we build our nodes. This is what the node needs to have. Two pieces, value, whatever we're storing there, and we need a node pointer. And so our node will keep pointing and it'll go on. And I'm just drawing it like this so I don't waste a whole lot more space. And when we get to the end, the final node is null terminated. So put a little X to mark that it's null terminated. Since this is the box for our pointer, we're going to use null pointer here. That'll cover it just nicely. But we want to start off a little bit slower. Let's just start off with A pointing. Let's do it like this. A is pointing to a null pointer to start with. Maybe I'll put values in here. So, I don't know. Let's use doubles. You guys want to do doubles? Let's do doubles. Let's just do them sequentially. 2.2, 3.3. Kind of makes it easy to track which one we're on. So this is it's a linked list, but it's an empty linked list. Where it points to just a null pointer is empty linked list. If it points to just one, this is a one element linked list. And And I think I've done everything I want to point to or draw right now. Again, this is our node, and we need a spot for our value and a PTR when we create it. So we're going to create, we could use a class or structure. We'll start with, fuck it, what do you guys want to start with? A class or structure? Class, let's start with a class. All right, let's switch this over to my laptop. So we've got our class node, and we need a private section and a public section. Is everything coming through on the screen? Okay, good. For now, I'm going to put our elements, our data pieces in public. We can move it around later. Takes time to set get and set methods. So we'll do like double value, I don't know, and we'll do a node pointer. Let's call it next node. So this is like a self-referential move right here. We're referencing to the class itself. That'll be our start. All right, let's come down here and just play around with it a little bit. We'll start off with a node pointer to, we're calling it A, so we'll use A. And we can set A to null pointer right away. That was our first box. Now, what we want to do from here on, we only want to do one thing with A. Okay, assign it to its first node. We don't want to do anything else. After that, everything we're going to do is going to use like a temporary node. So I'm going to make a temporary, I'll say that right here, we'll use a temporary node for everything else. Because we can always reassign shit, which is handy. So let's make a node pointer, call it temp. And I could say null pointer right away, but we could just go to new node. And it's probably good to set that to null pointer for now. And maybe I'll do the value first. My first value was 1.1. We got in our new node, we got a temp value, we got 1.1. We'll do a little print routine in a second. What I've got going on right now is the following. We've got A pointed to a null. And I've got a box here with 1.1. This is null terminated. And temp is pointed to it. I want A to have this chain. I want A to be in charge of it. So I can go ahead and tell A to be equal to temp because it's a pointer address. So that's handy. A equals temp. And now that is the last thing we really need to do with A. Change with A, I should say. We'll do print commands and stuff like that.
Professor?
Yeah.
We don't need to do a next node equals 10. We just said A to.
Haven't done it yet. We're getting to next node.
Okay.
Getting there now. So all I've done so far with saying A equals 10 is I've done this. A is no longer pointed at that null. A is pointed at temp. And that's temp next node right there, currently. So what we want to do next is we want to add another node there. And we want this one to be null terminated. We said we're going to make this 2.2. And we need that one to be connected to here. So this will no longer be null terminated. It will point to a new node. So we want temp next node to go to a new node. Okay? So let's do that. Temp next node equals new node. All that's done is created a node. Temp is still pointing at the 1.1, that node. So what we can do if we want to keep working, we want to work with that new node, we can redirect temp's pointer to be equal to the pointer for the new node. Right? So what we've done so far, I haven't done the 2.2 yet, but we've created the new node and I've now pointed temp over here. And now the only way to get to the 1.1 is through A. We've lost the link to 1.1. That's the only link to A. Let's do the 2.2 and the make it null terminated. So now that I'm at the next node, now it's easier to assign the value there. I really like that it converts the dots to arrows. It makes typing it so much faster. All right, so now we've got two nodes here. And if we want to do it again, let's see what we're doing here. Because this looks like it's going to become a pattern if I do this right. What I'm doing is I make temp next node. Now this is temp next node. That one's not. And what I want to do is like step one, I want it to point to a new node. And then two, I want to redirect temp to look at that node. Because if I want to otherwise do this, I can access the value here right now without moving temp, but I would have to go temp, next node, value, and this gets confusing really quickly. But if I redirect temp by saying temp equals temp next node, no, just that, and we got that. That gets rid of this pointer right here. 2.2 has got only arrow is from 1.1, which is from A. And now we've got this pointer here. 3, we should assign it a value. Or null terminated. And that'll block it off. And this becomes a cycle we can repeat. If we go through the cycle again, it takes, I didn't write that very well. Maybe I should write next node equals new node. That's a cycle we repeat. We do one, it gets rid of the null pointer there, it points to a new node. Then I do temp next node, so my arrow changes over here. And then I can populate it, and I can do null pointer. So it's a sequence that we can do. Let's come over here and activate that. Let's do the next few. Shit, it's those four right there, right? I will change that one to say 3.3. And I can change that one to say 4.4. So now I've got what I've got on my paper. And how do we take a look at them? I'll start up here. Temp next node, we can do like see out what's in temp. Temp value. And we'll just do that as we're going along the way. Put it after each one, just to make sure that this is working correctly. Notice I've only assigned A to temp the first time. If I reassign A to temp later on, I'm making A point to a different spot than 1.1, and I want it to be a 1.1. Let's give this a run, make sure we didn't fuck anything up. Not bad. So this feels like it could be really, really slow, like to get to like the 300 element if I wanted to print out, because I have to start at A. Like even to print element 4 right now, if I just start with A to print element 4, I gotta jump next node a few times. Like if you've got a giant database, like you want to go 300, you got to jump it 300 times. And so like, to me, it sounds like that's a lot of extra work it's doing, but that's already what it's doing here. It's telling it to go to the next node, but the node is right next to it. So it still has to tell it to do it. It's just a pre-built-in thing for arrays. So let's not worry too much about that. There is another way, like I was saying, we could start off with, let me do a little quick. And we'll do see out A, not next node, A value. And then I'll insert a space. And I could see out A next node dot value, and I can insert a space. I can do A next node dot value, and that should do the first 3 right now. Like there is more than one way to print him. I can do that. So you can get to the later nodes without jumping to, A is continually pointing at 1.1, it hasn't changed. We can keep doing this cycle where we have as many next nodes in the sequence as we need, but that's tedious as hell to type. Can you imagine how much code it would be just to do like 10, having next node 10 times? Even if you abbreviated it just N, pointer N, pointer N, pointer N, pointer N, it would fucking suck. So this isn't desirable or not. This cout method isn't feasible. Using a temp pointer is much easier. So If you fuck with A though, you lose the beginning. Never fuck with A. Just assign it at the beginning to the first temp node. I don't need caps locks for the whole thing. And I didn't turn off caps locks, there we go. Just assign to the first new node.
Would it help to make it const?
No, because we had to redirect it in the first place. Like maybe if you did, I don't know, maybe it might work. Let's give it a try. We could bypass all of this part. Can we do const node pointer A equals new node? And then I could just say, to work with temp, have it point to A. Will this still work?
Oh, you can't assign, I don't think, can you assign a regular node to a constant?
Yeah, I don't know that I can. I'm looking for my error log, where the fuck is it? So no, we can't do that. So we can't make it a constant. I like the idea. If we get rid of the constant though, we should be able to do that. And that would still work. I'm gonna go back to node A just being there because we wanna automate all this shit. Like automate a first node, automate adding nodes and stuff like that. Let's make a print function.
I think you need to set it back to your new node now.
Good call. We're just pointing at each other. All right, void, let's do print singly linked list. And what do we need to do this? We actually, all we need is the node pointer. So let's go design that. Okay, so we've taken in the pointer. We should create a temp node in here, work with the temp node, equals arg ptr. Let's always work with the temp node. Never want to fuck with anything. So like, back to the paper. We obviously want to go through a loop here. To go through them. How do we figure out what to tell it to stop with? Like, when do we tell it when it's at the end?
Next node should be node pointer.
Bingo! Excellent. Let's do that. So, while temp next node maybe isn't equal to null pointer, we keep cycling. So we want to like see up temp value. Inline. Then if I just do that, that's not enough. Let's come up here and comment that shit out. Let's install a print. Why doesn't it want to take it? Did I not spell it something right? I had it spelled right. Like, as it is now. I have, it's going through a cycle, I haven't broken the chain yet. So we need to, when you do it, you also need to make sure you advance the temp to the next pointer, to the next node. So let's see what that gets us. It only printed out the first three, so we need to do another C out. So maybe we should C out temp value right here at the end. All right, so this works with a list of 4. Let's go ahead and make sure it works with less of a list. I'm gonna comment out like 22 to 44. Let's just comment it out. We can bring it back in a second. Should just have a 1.1. So it can do a 1-element list. It can do a multi-element list. There's only 3 scenarios like in math that we give a shit about. 0, 1, and more. Like there's 0 solutions, there's 1 solution, and there's like infinite solutions. So we've covered infinite printing. We've covered printing 1. We need to cover printing 0, which means commenting out this one. And so we might have a problem, we do have a problem here. While temp next node equals null pointer, and if we look at the code, A was never assigned to next node. So we need to edit our print singly linked list here real quick. Let's end that run. We should do something like if next node equals pointer. Equals null PTR. We'll tell it to see out empty linked list, maybe. Does that sound good? The list is empty. And then we want to do a return. We want to get out right away. Nope, still causing a problem. Why? Not if next node equals null pointer, if temp equals null pointer. Duh, I'm putting in the second element. We want to do the first, undo. That was the wrong one. I want temp to point at the first damn one. I love CSCI, it fucking tells you what's wrong. All you gotta do is read it and go, what did I do wrong? It auto-fills in shit for you. It's like the biggest cheat. All right, so everything's working. All right, so we've got our print list going on. Maybe we could create one that prints backwards. Let's do that. Let me uncomment all this shit. What happened? There we go. Let's make sure everything's working real quick. Nope, let's fuck that. Oh. There it is, okay. Back to working just fine. Let's look at maybe exploring print in reverse. You know what? I'm gonna hate typing that out. So let's do print reverse singly list, linked list. That seems smarter. Now, we know there's a good chance we're gonna want some of this shit in there, so I'm just gonna copy it over. Because that's this is the loop to get to the end, right? This loops to the end. So if I get out the C out temp value there, I get a nice little loop to the end. We kind of want to leave that first one in there. If it's null pointer, that seems like it should be part of it. Any function we write with this stuff. So we're gonna have that if in there. So like this one jumps to the end. And I could print the last one. How do I tell it to print like the second to last one? Any ideas on how I could go about and get to the end and then like print 4.4 and then I want to print 3.3 and then I want to print 2.2.
Recursion?
We could do recursion. Wonder how we do that. We tell it to go to itself and then I think you could. We'd have to work, it might be easier with a counter.
You'd have to also make another parameter for
For what?
like recursively, if we're doing it recursively. So otherwise,
Oh, instead, while doing this, we could do, let's see. If we did it recursively, we got the temp, each time so each time it needs to pass it.
like we'd have to set up a counter and then.
Instead of doing this, we would have to do node or print reverse singly list, linked list, temp, next node.
I was just thinking if on each call you're printing it, and once it got to like the last one, wouldn't it have to print like the last element, then it would return to the previous call, and then it would print the one before? And so in that way, it might do it in reverse.
That's how we can do it, but the CSCI line's got to be after it.
Right.
Right. So that's what I'm doing. I'm getting to the end.
Yeah.
C out temp. Okay, let's get this right. This should get us to the so right now I've got while temp next node is equals null PTR. That's going to give us a problem. Is not equal to null PTR. That's our cycle right there, and I'm telling it to go to, or print the next one. We're going to have a problem when we get to the end, because when we get down to the final one, I can see right now. When we get down to the final one, where we're at the final node, this is going to trigger first. And I can't get rid of it because if I send in an empty list, this is gonna get pissy. So we can't get rid of this. And yet, if we do this, it's gonna get down to that last node, and that's gonna trigger on the final run. And then we'll never get to see the rest of it.
we had an iterator at work, but that's like later on. Because you can go iterator, you can go backwards.
That's double E, we're gonna do,
Okay.
we'll do double E later. So, let's put the recursive idea on hold. I like the idea, I think we'd have to figure out a way to get past this and acknowledge whether or not it's the first node. Like if it's the first node, if it's the first time we pass it in, then this triggers. But that would require like passing in like a counter. Maybe we could just avoid the whole counter thing. Or passing a counter and just make a counter. Let's just start the count, like a counter as 0. And maybe while we advance, we also do count plus plus. Because that way we can count how many nodes there are, right? I'm gonna see out counter real quick, make sure, see what we're getting real quick. I think that's the only thing that's printing out, that and the last one, 3. So it's one short, because there's 4 nodes. So we could either add an extra counter plus plus here, or fuck it, I'm not seeing out the count in the beginning, just change the initial count to 1. If I change the initial count to 1, this will trigger a fault, but we're not printing out the counter. And we don't care about the rest of the entire function. So I don't need the counter anymore. So here, this is just, that'll get us how many elements there are. So now maybe we gotta do like, run through a cycle. So maybe we could do some nested for loops. We got int j equals 0, j less than count. And I don't know, j plus plus. Oh, that's not the right symbol. There we go. Counter. And okay, so that's gonna go through the counter, and what we want it to do is go all the way to the end. So maybe for int I equals 1, I less than j, oops, I less than j, I plus plus. Is that gonna do what I want?
I wonder if you can go backwards, like j equals counter, and then j is less than 0, j minus minus.
That's what I wanna do. Counter. Hold on. We wanna start at the, say that again?
So the very first one for j, set it equal to the counter. And then j is less than 0. And then j minus minus. That way it starts from,
J is less than 0 is never gonna trigger. J greater than 0 will trigger.
oh yeah, j greater than 0, j minus minus.
So that'll start us at the end.
And then for that one, we just iterate all the way to the very end for the inner for loop,
Right here?
inside of the inner for loop.
Oh, in the, yeah, so the inner for loop.
So we would make another for loop that iterates to wherever the counter is. And then put the C out inside of that inner.
I less than J. Not necessarily where the counter is, but where J is, right?
Yeah, yeah.
And we want I plus plus. In here, that's where we're doing our temp next node. And then we want to do that right there. Let's give it a run. You know, that's funny, because that's the way I had done it when I did this. And read and did it some back-asswards way that I was trying to do the first time. And it fucking rude.
Access validation.
Oh,
Oh, is it counter minus?
I know I did. End program.
Oh.
What the fuck? We did the while loop to get the counter, but then I didn't send temp back to equal to the arc pointer. We were already at the end. That's what's missing. I gotta restore it to its initial point. Fuck off. Oh, it doesn't like. Why don't you like the last one? Oh, because after the first loop, it's still stuck at the fucking end.
Oh, you have to like put it back.
So I gotta do temp equals arc pointer in here, don't I? And then it'll go, it'll rate less, it'll print, it'll reset.
I wonder if instead of putting the both temp arcs, you can put the first temp arc right above the inner for loop, and then you don't have to do both of them. So like on line 97, just
Oh, I see what you're saying. And fuck, do a little bit of refactoring, save us some lines. I like saving lines of code. Let's do that. I'm excited to do this. Why do you not like this though? I don't know. We're gonna fucking run it. Maybe it's just me. Nope, it doesn't like it.
temp was null.
Alright, J is for J greater than 0. So we're telling it to jump forward 4 nodes.
Maybe J minus 1 underneath that? No, because then that would be 0 and it'd be negative.
Might be giving us a problem. Let's try it.
Oh, you eat it.
Ah, did it.
That works.
That's what was missing.
What did you change?
I'll show you. Let me put some shit in here. Let's add another end line in here. /n. We changed the counter -1.
Here's access.
Okay.
Now, this is something handy. I'm gonna undo that counter real quick. I'm gonna do this. I'm gonna say,
Counter minus 1.
this is how you fucking test your code. Go, where the fuck is my error? Do C out,
Oh,
step 1, end line, see if it gets you into the program. C out, step 2, end line. We're C out, step 3. That one shouldn't be a problem because we knew that loop worked before. Maybe inside the loop, do C out, step 4. And then in here, C out, step 5. And finally, right here, C out, step 6. Because we knew it was giving us a problem, it wasn't running. But now, if I had all these counters in here, when I hit run, oh, son of a bitch, it's not even gonna do it. That's rude. I've done debugging all the time using this and it didn't fucking run. It hates me. All right, so let me comment those out. What we did is we said J was going too far. It was trying to go to a node that wasn't there. Get out that, get out that. All right, let's print it again. MFR.
Say you erased the, I don't know what it's called, the bracket,
Did I miss a bracket?
in the if, when you type step 1, step 2, sorry, you erase the closing.
Follow the dotted lines. They tell you where they're going. Thank you. That should work.
There we go.
All right. So we got our thing going. Let's see. Okay, so we've made those. Let's automate adding a node. Let's do that void
Oh, that makes sense.
add node, maybe end. Or add end node. Let's do add end node. What I need to pass in. Oh, this was a bitch. I remember doing this. We need to pass in the pointer. But doing this alone isn't going to be enough. We need to pass in the pointer by reference. Let's try it this way. Maybe Visual Studio is 2022, and let's fix it right here. Arg head pointer and double arg. Put it up here above the print. You know the print's working, don't want to have to scroll through it later on. Don't need that. So we want to do these steps. That needs to be what's going on here, but now we need to edit it to what we're doing here. So let's give it a no pointer temp equals arg head pointer. And we want to add it at the end, so we actually need to iterate to the end, right? So let's go grab our iterator to the end. And we need that, then we need, if we do that, we need to have the if thing also, because it gets mad if we try to tell it that we're gonna get rid of the C out in it. That should iterate us to the end of the pointer. So this is our loop to end cycle. Oops. And now this is what we're doing. We're going to do temp next node equals new node. We got to give it a new node. We'll jump to the new node. We assign the temp value equal to our argument coming in. And we see temp next node equals null pointer. That make sense? Let's go test it by adding up 5.55. Worked just fine, didn't need the fucking ampersand. So that did get fixed. Good to know. All right, we added a note at the end, maybe add a note at the beginning? You guys wanna do that? All right, so let's pictorially sketch what's going on with adding a node. Well, we already know adding a node at the beginning. That was just the first step. So let's do like add first node or add head node. Should have the same setup. I do need to sketch it though. I'm like, yeah, it's easy to do when you don't have any other node. But like, let's go back to our sketch. Let's look at this and figure out what we're doing here. So like the recursion thing didn't work for us. Let's say we've got A and it's pointing to 1.1 and that's pointing to 2.2 and I don't need to show any more. Let's say that's all there is to it. And what we want it to do, we want to create a new node. So we need to create a new node. So step one, make a temp node equal the new node. It's got to go there. We got to have a node first. So this temp is pointing right here. I'm gonna write temp there and do this. And what we want to end with is we want A to point here and this to point there. So maybe, and we also have the value. So we do the value real quick, temp value. And what do we want to do with the temp next pointer? The temp next node is got to point to our head pointer next node, right? That's what I'm trying to tell it to do. This is A's next node. I wrote A, use A here. A's next node points to here. I want temp's next node to point here. And so everything is done so far, except, no, I don't. I don't want it to point there. I want it to point here. Right? I got all excited, the 2.2 fucked me up. I don't even, temp next node has to equal A. There we go. That works, right? Temp next node equals A.
Whatever the parameter we put in, which is
What?
like whatever we named the parameter.
Yeah, what do we name the parameter? I have it listed as A here. And then all there is left is to erase this arrow and point this over here. And so we'll say A equals temp. Does that seem like that'll work? We made the new node, we put its value in, or we made the new node, we put its value in, we directed its next node to point at A, and then we directed A to point at it, which sounds kind of funny, and it sounds exactly super stupid if you were to do it in real life, But in computer science, it's the, since we're doing assignment, once the assignment from temp next node equals A, that's all that matters. Now pointing A to temp, oh, wait, yeah, next node. That's the next node pointer, but temp is still here. So A is still pointing to temp. I think that's gonna work. I think that's gonna work. Let's give it a try. So we need a temp node pointer temp equals new node. And we said temp dot value, God damn it, equals arg. And I had temp next node equals arg head pointer here. And then arg head pointer here equals temp. The only time we do anything with arg head pointer is at the end. So like adding or referencing anything doesn't affect it. Let's go ahead here and try it at the end. Now we'll add head node. We're passing it A, and let's go with like 0.15. 07, 007. Didn't do it. All right, well, why didn't you do it? Did you even get here? All right. It did both steps. So it went through this cycle, but did not assign arg head pointer to temp, which means this isn't our real arg head pointer, because otherwise it would have fucking changed. So maybe we need to pass it by reference.
We still need to put the pointer at the bottom.
What?
Then you changed it from node pointer to node reference arg.
Yeah, we just want to add the ampersand. It's a pointer and we're doing a reference to the pointer, so we'll pass the pointer by reference. So this passes the pointer, the node pointer by reference. Let's see if that works. Bam! I can get rid of that step 1 and step 2 bullshit. Do you see how that helps? Like, just throwing in some CLs, see if it goes through the fucking code like you wanted it to. That's pretty handy. It can really, like, fix shit. All right, well, now what do we want to do? We could add a user interface, we'll do that later. Let's, we got a lot of functions, right? Maybe we should, like, make a new class. Let's make a linked list class. Our linked list. let's start off, let's make the only thing this thing needs is the head pointer. So no pointer head. And what we want to do is, well, we need to make a couple get and set, right? So we need we want it to return a node pointer for get head. Void. And we want to do void set head. I'm going to pass the node pointer. We also should have a default constructor. That's not the default. Our linked list. And this will pass it the null pointer. It doesn't like that right now.
So we have to set it equal to.
Yeah, there we go. All right, we need to make these down below. Once we do those, we'll turn these other ones into code. Our linked list, we need to scope it. And output. There we go. We're gonna have to do set head equals arg. So if they pass in something different, it will override the null pointer. Not equal to arg, set head arg. Then we have our linked list, get head, returning a node pointer, return head. I use lowercase, right? Yeah, lowercase. Return head and that was that one. This one, add our scope resolution operator here. And head equals arg.
Wait, do we need to do a constructor for the node then as well? For those two? Or no, we don't need to.
We haven't made one yet. The node's been run the whole goddamn time. It makes a default constructor for you automatically. But that's probably pretty good programming. We should probably move these up, but I want to make sure we get through as much as we can. You guys will be able, you guys can make get value, set value, get next node, set next node. This will be something for you guys to do because I know like the assignments I'm about to activate after this will use this stuff. I can get rid of all this code, can't I? I can get rid of all that and just do let's clean up the code a lot before I add the other ones. A 1.1. Fuck this. For int I equals 1, I less than 6, I plus plus, add and node a I times 1.1, that'll do it. That'll give me that same list, right? And I can comment, I'll get rid of all this shit. This is all extra extraneous stuff. I don't wanna get rid of the top one yet. We've got everything running there. We want to use this, our linked list here. We want to do our linked list. My list maybe? And we just saw that we set it up so we can pass it up the null pointer. But we don't even need to do that, because that was our default. And that's where I need to set my list. My list equals 10. Did I call it my list? No, not my list. My list dot head. It's pissed. Something's off.
I think you have to put it in the parentheses. So you can like
Put what in parentheses?
the head itself. So in this case, I think 8.
Head, like that?
Oh no, like well, the head of your linked list. So the note that you did was 8, right?
No, 10.
Or yeah, 10. So would it be like my list?
Well, the constructor's already called.
Set head method.
Why isn't anything popping up?
I think, do you need the parentheses on that for the default constructor?
Because that's just the name of the class. It's an object.
My list head, set head, there it goes.
It just took a second.
And now you put it in parentheses.
Yeah, you're right. Alright, theoretically, I don't even need A anymore. Get rid of A. A's not doing shit here. M, F. A is an undeclared identifier on line 4951. Okay, I still have A referenced here. My list.
My list dot head.
Add end node was taking in a node pointer, so get head, yeah. My list dot get head. If I can get smarter at this, just copy and paste once. Why do you not like it? How are those different? Oh. No. Now it doesn't want, if I do it, it doesn't want this anymore. I don't think it wants the reference anymore. Moody son of a bitch. Yeah, there it goes, now it works. Or, no, it doesn't, still telling me to fuck off. Let's see, line 67. And line 24. Line 24 is what? Oh, I sent, you know what? No pointer isn't. I then created a new node. Leave it like that. Still doesn't want to do it. So I need to go new node. I don't like this.
Yeah, because then you would have to actually do a constructor.
All right. Fuck all those. Let's get these things inside and adapt them, and then not worry about, because the hard part we're having right now is passing the fucking linked list. If they're in here, we don't need to pass them anymore, right? If they're in here, we don't need this node pointer anymore. So we don't need to delete the rest of the code, we just need to make code for this. So I'm just copying all that. And we gotta go through and edit them down below. So we've got a bunch of our linked list shit set there. I'm gonna quickly scope them all real quick. Got little setups for them. And now we wanna copy what we got going on. So print singly linked list goes near the bottom. Let's just copy it as is up there and then see what we need to edit. Node temp, there is no arc pointer, it's now just get head. That should be the only change right there. I don't see anything else referenced for the argument. Let's grab the reverse one. This one had a lot of shit going on in it. Okay,
The one that does change is the add head at the beginning, right? Because we're changing that one from its beginning head to the, if you're adding a head.
what?
The add head to the very front function.
Yeah, I haven't made it, I wasn't working on it yet.
Oh, gotcha.
Wait for it. Like, fuck with me, what are we doing here? What's going on? Temp equals get head. That might be it. All right, add end node. Come up here and paste this in add end node. And node temp is get head. You know, I'm hearing what I'm saying right now and it doesn't sound right. Oh well, fuck it. That's what we're using. And that was it. And finally, add head node. So what were you saying needed to go into add?
For the add head node, because it does change, would we have to mess with it as well?
Yeah, let's see what we're doing here. So we've got a new node, we're making a new node, we're assigning the temp value. We gotta do set head, temp next node equals, no, get head. That does that. And now arg head pointer doesn't equal, we gotta do set head equals temp, right?
Oh, yeah, yeah.
So, I think I did those all right. Gotta come up here and make sure like what I'm doing in the main is fine. So, I got my linked list.
I think if you get rid of those two parentheses, I think right now it thinks you're doing a function call. If you do that, it'll use the default constructor.
You're right, that's what I was fucking at, I was pissing it off.
I was thinking of also just moving the entire like variable below the new node part, and then that way the new node has already been done, and inside of the constructor you can just put it all in together.
We could do that. I don't wanna do that, I like having my
Yeah.
things that are there the whole time from the beginning. Now to add, I don't need to do this function anymore. What I need there is, if I wanna just stock a bunch of them. I already got one up there. I can do, it's called add end, right? And it's my list dot add end. I times 1.1. I don't need to pass anything, I just need to pass the argument. And add head node is just my list. Add head. And now I don't need that. Now all I need is my list print. And my list print reverse. That does both of those. Other than I want to kind of have that up there. Let's comment that out. I think everything's gone there. Motherfucker. All right, line 75 and 24.
Yeah, I don't think you need the equals.
Oh, but not there, definitely not there. That's a problem. It's only up at top. That might have been the only problem. There we go. Yay!
That's cool.
Wasn't that fun? Got all that written out. Oh, something is missing. We have a bunch of new shit being created in our thing, don't we? Our class has a bunch of new nodes being created in add end node. Add end node. Add end node or add head node. We need a destructor. Our linked list is what it's called. Yeah, we need to create one down below. The end of our linked list shit. So this is. We should go through and destroy the nodes. Which means doing like the print reverse, but instead of printing them, destroying them. Yeah, because we want to destroy from the end. So let's come up here and grab our print reverse function. And let's see. Make it a counter, we get set back to new head. We get to the next node, and then we want to delete.
Do you want?
Okay.
Okay.
Delete temp. Deleting node.
But we still wanted to set it to null, no? At the outside.
Ah. Yeah, because the pointers still exist. So before I delete temp, I'm gonna set temp next node equal null pointer. Because those pointers still exist for the life of the program.
Is it possible to just, like at the very outside of the for loop, could we just set 10 equal to null pointer?
That would get rid of the final one.
Oh, I see.
Oh no, when we get down to J0, that should get rid of the final one. Doing it out here means it's going through the entire loop before we delete. There we go, we got our nodes deleted, we got 6 nodes. The nodes have been deleted in reverse. Whether or not you want to say the C out, I don't know that you would, maybe just say one C out, headline, nodes, and our linked list deleted. Then deallocated. Okay. Well, we've got an add node at the end, and we've got an add node at the front. There's only one other spot we can add node at. You guys want to do add node middle?
Top node.
All right, we're gonna have to figure out how we're gonna do this. So let's come up here and name it. Oh wait, that's the wrong fucking section. That's the functions. I don't even need those anymore. Let's comment that shit out. And we're not using them down here, so fuck them. They're easy, they're distracting me. If they're green when I get to them, then I'm not so worried about it. There we go. Comment that out, that way when I'm scrolling, I don't get distracted. All right, we're up here. We're making add bid node. Well, we need to be able to tell it where we're entering it, right? We can't just pass it in the argument. So we gotta be able to pass it a node pointer as well.
Or I guess it would depend on how you wanna do it, right? Cause like you could count the nodes and you say, oh wait, no, cause
Yeah, it depends on how do we want to decide where we're gonna insert it. This all would affect how we're gonna do it.
I would think you could pass like an index, say like I wanted to add the second position maybe.
but first we'd have to have a counter and then say, okay, this is your options. And then be like,
So we need a method that would tell us how many
how many?
are in the list.
Right, yeah.
So we want to do that, let's do that though. Let's do int arg position, our arg index, that's a good choice. And we also need a void. Nope, not a void, it needs to return something. And find total or total nodes. I don't know, void. Let's come down here and prototype the shit out of these bad boys. And do them right here. Nope. Let's do them near these two. I think this one's easy. This one is just go through the fucking print reverse. We got the counter thing right there. And then return counter. Right? I think I need to start it at, oh no, I can say return 0 here. And then when we get to the loop, we just say return counter. Right? That would give us our total nodes.
Oh, we can't see that.
We can't what?
150, we have a seal. And it's returning it to you. I don't
Yeah,
know.
I guess we don't need that, right? We just wanted to return the 0, we wanted to return the count. That's good. That's not gonna affect our admin node, but we can do some checking right there. Like if arg index is greater than total nodes. Then say something and return it, maybe. Yeah, this is past the end of the list. And return. That would make sure that we could use, that's our data validation. And now I guess how would we use that? Maybe do a for loop in I equals 0. I less than total nodes, or not less total nodes, less than arg index. I plus plus. We're gonna do, we need temp in here. I got that backwards, fucking scrub. Do I want new node yet? No, I just want temp to be get head. And we'll advance through temp. That gets us through to that index. Now, this is where we need another node. So like, let's say, so this is adding after arg index, right? Add a new node after arg index, the way I've got it set up. If we're iterating to it, we're gonna add it after it. Then I'm gonna need another node. Temp2 equals new node. Temp2 value equals arg. This is kind of like our add head node. We're doing this part right here. So now temp2's next value needs to be temp's next value, right? And then I'm gonna reverse those. Temp's next, well, not reverse, but temp's next value equals temp2. We're not doing set head anymore, we're not doing get head. We're getting those positions. I think that's gonna work. Does it look like it's gonna work, guys?
I think, like, just in case the list is empty, we have to put a check for that.
Oh, yeah, let's go grab that. Yeah, we definitely, oh, not that. If get head equals. Ah, fuck it, let's do this after anyway, node. Not returning anything, that's all I need right there, right? Let's go try that out up here. Where's my main? Before I add head node, let's do my list. Add mid node. We want it in position 3, I don't know. And we'll do 7.77 or 1.234. So is this doing what I think it's doing? Let me change this. Let me comment out the add head node. Because that's changing the length of my list after I fucking did it. This is adding it after the 4th one, not the 3rd node. Which means maybe I need to do -1.
Yeah. I think it's because it's the first one starts at 0. I'm assuming. or equals to.
Let's try it. There, now it's adding up to the third node. Let's see about. What happens if I say do that as the 0 node? The fuck am I? Close that, that's what's throwing me off. Let's try adding. There it is. My list, add mid node. What if I tell it to add it in the 0 position? Can I add it at the first with mid node? Not the way I've got it set up. No, that's not true. We're telling it to add it after the node position. So, that makes sense. This is entering it right where we're telling it to enter it.
So would it have to be like -1 for it to like?
But there's no -1 index.
Well, if we want to add the first, we would add head.
We already have add
Yeah.
head node, so that's good. What if we do like send it at my list total nodes? What happens if I send it? That should be the end, right? And it did, added to the end. So that's another way to add to the end, but that requires us to tell it to like add at the end.
And then
Of course, with that there, we could just take this and put this, we could totally refactor our code right now, right?
Mhm.
I could take this and say, fuck off end node. Right? We could tell it, I'll comment it out. We can just flat out just tell this, go fuck itself. We don't need my list at my list thing. We'll just do add mid node, total nodes, arg. Did we just like refactor this, a whole fucking method out? Did we just do this? Hell yeah, we just did this. Fuck yeah. I'm not gonna delete it because I'm gonna post the code. So we've got add middle, we got add head, we got add, you know what? Fuck end, or let's call it tail. Heads and tails, you know? Add head, get tail. There we go. That sounds completely fucking inappropriate. But I'm sticking with it. Where are we? Add tail node. And do it there. And I know it shows up down
control
here.
and find and replace.
Where the fuck is find and replace? Control F, does that do it?
Yeah. And then at the bottom it tells you like, or the side I think the
So let's just find end.
or the, which one is it? So,
I think I already got them all. Yeah, alright, so it works. Did we go through the whole fucking, everything I thought I was gonna need to do, like partially on Monday too? Go us. Any questions? Alright, let me go post this shit in class. I'm sure we could do some more refactoring. Copy. I don't know if you've heard, Amazon is now working with COS.
Oh, really?
Yeah, so like if you have anybody in your family that works for Amazon, you can have them look for Amazon on the COS website. Fucking lies. Where was it?
Career choice.
So maybe there's, yeah. So if you know anyone that works for Amazon, they're like offering payment for all your tuition and reimbursement of books and fees and everything like that for employees that have worked for 90 days or more.
Oh, I like that.
And I know we've got like a facility here in town. So this was just emailed me today. And I remember when I was looking at it, it said it was, where was it?
Work there like minimum hours.
Yeah, as you get it.
Just enough to say.
Yeah. Well, you gotta keep working there.
It's like 2 hours a week or
Where was
so.
it?
Just enough to qualify.
That wasn't what I wanted.
You're in the bathroom the whole time.
Yeah, there's just, I mean, they're like Uber driver or something.
Yeah, well, I don't remember where I saw it last night. It might have been in the email. But yeah, they're reimbursing shit. All right, that's not what I came over here for. I came over here for our class. And maybe I should go open some shit for you guys. Because I know Amitesh has probably got all his fucking work done already. And I think I did probably a lot of this shit for you. We'll find out. Open the, okay, did those. New announcement. Lecture day 7 notes. Here's what we did today. Okay, paste as plain text. I've learned this is a bitch to make it look like the way I want it. And then come up here and say pre-formatted. And then when I post it or publish it, all looks well. We did a lot of stuff.
Yeah.
Did you guys understand everything we did?
More or less.
More or less?
This is a harder, like, I remember for, at least last year, it was like one of the harder,
It's a hard time. It took us 2 hours.
it's a harder concept to get over.
I think this doing, like when you're doing it, if you try to do those things without looking at the code that we did today, writing out what you're doing and pointing, going, okay, how is things redirecting as I'm doing it? This might like help you with the process. I know it like helps me think it out. Writing out what's going on helps think it out. I guess I can scan these.
I try to make like something for the SIs as well.
Sorry, Kenny. If you guys, sorry. In the future, say something. If I lose you guys, say something. It is a little bit hard to follow. I think I was going a little bit fast. Like I'd hit something and then I'd go up and just try to run it rather than giving you guys time to see what I was doing, I think. But it's there to look at. You heard the talk through. And I will, even though like I don't know that I need to do more on this on Monday. Monday's class, I'll still be like doing stuff. I'll be online Monday night. If you got questions anytime during that 2 hours, pop in. Because what we're doing on next Friday is doubly linked lists, so we're going to modify this to go the other direction, which isn't as hard as it sounds. This was the hard part. But there's some finessing that's got to be done with it. So Monday will be, like if you got questions, come ask questions. Okay? All right, get the fuck out of here. It's Jefe. I know it sounds like Hefe. It's Jefe. I know, that's okay. Have a good weekend, B.